All right, so welcome to my week 8 problem 1. This is going to be the 4-credit problem. This is going to be problem 29.22. So here we are told that the value of the line integral of b around this closed path in this figure that we have here is going to be 12.59 times 10 to the negative 6 milliteslas, and we're trying to find the value of I3. First thing we're going to try to do is to somehow relate this the total current to the line integral of b of that value. What we're going to first just try to put this in terms of equations. So the that value, which is 12.59 times 10 to the negative 6 milliteslas, is going to be equal to this mu naught, which is the permittivity of free space, times the total current. And due to the fact that this permittivity of free space is a constant, we actually know that value, which is going to be 4 pi times 10 to the negative 7th milliteslas over amperes. So now this is going to give us a value for the total current. So isolating for that I variable, we're going to divide both sides by that permittivity constant to get 10 amps for the total current. So now going back to this diagram, we're going to try to find which of these are going to be positive, which are going to be negative, because this is going to ultimately help us figure out what that value of that third missing part is. So we know that I1 and I3 are positive. They're going to be pointing into the page, and I2 is going to be negative, or it's going to be out of the page. And we can also do this by using the right-hand rule. So now, I don't know why that says IN. That should be I2. Regardless, so we know that now, because those values are going to be both positive, that's going to be those two positive currents, I1 and I3, minus the negative one, which is I2. That's going to be equal to the total current. So substituting everything in from that first part, we calculated the total current to be 10 amps equals, and then using the values given above us in that first diagram, 2 amps plus I3, which is the one we're solving for, minus 6 amps. So finally, that remaining value is going to be 14 amps. So I guess just some of the tricky parts is trying to relate the the variables that we know and the ones we're trying to solve for. So knowing that we can get that total current, and then solve for its parts, knowing which ones are out of the page, which ones are in the page. So that was, I guess, some of the tricky parts. And yeah, this just has to deal with using Ampere's law, which is like that fundamental equation that we started using for this problem in the first place. And yeah, other than that, that will be problem 29.22. Thank you.